Hello, my name is Tori Wolters, and today I'll be talking about my project mapping mangroves in the Caribbean using high-resolution satellite imagery. Mangroves are tropical and subtropical species native to the Caribbean, and in their native environments, mangroves provide many benefits, such as nurseries for coral reefs, habitat for species of birds, mammals, and reptiles, foods and other goods used by humans, as well as coastal stability and storm protection. In spite of their importance, mangroves are considered some of the most threatened ecosystems worldwide. Some of the threats to mangroves currently include pollution, land use changes, coastal development, exploitation and cutting, and sea level rise. And because of their importance, it's necessary to understand the current extent and status of mangroves, but for most of the world that remains largely unknown. However, there are two main global databases of mangroves that exist: the Global Mangrove Watch, which was begun in 2010 and then updated in 2016, and the USGS map, which was from 2010 and published in 2011. So for the past decade, the USGS map has been considered the most consistent on the global scale, and then additionally there have been many studies that have been conducted on the regional scale, but few of those have been in the Caribbean. So for my project, I was working with the Nature Conservancy under the Resilient Islands program, which is a partnership with the Red Cross, with the goal to help make coastal communities less vulnerable to climate change by using nature-based interventions in policy and community planning. As part of the Resilient Islands program, we were tasked with creating an updated and accurate map of mangroves throughout the Caribbean, which then will be used to model storm protection and designate areas that are in need of restoration and protection throughout the region. So the purpose of my research project was to create that accurate and up-to-date map of mangroves for the Caribbean. So I had several databases to compare: the Global Mangrove Watch USGS map and a previously compiled map from the Nature Conservancy from 2013, and then satellite imagery. And using the satellite imagery, I was able to identify the mangroves based on location and physical appearance. So mangroves are coastal ecosystems, which helps narrow it down, and then they have a distinct appearance in the satellite imagery, which makes them kind of easy to identify, but still a little bit hard in some regions. So we coded each of those digitized areas, either as existing mangrove, new mangrove, or possibly mangrove, but we weren't sure for some areas. And I had a couple other people take a look at them for areas that I wasn't sure of. So we still need to get like a field check and spot check some of those different areas that we coded as possibly mangrove. And then additionally, I calculated the total area of mangrove for each of the islands from each of the different databases to compare the total area and see if it had changed or if those other databases were accurate or not. So here are some examples of our results. The pink polygons are the mangrove areas that I digitized for this project. So just a few of the different islands on here. So you can see they're all coastal. And some more examples. So throughout my project, I noticed that there were some discrepancies between the databases that I was comparing and my current map. So for example, this is the east coast of Jamaica, and these orange polygons represent the USGS map of mangroves, but clearly these areas, especially far off the coast, are not mangrove. But then in some other areas, our map, just here in the red, is very, very close to the other maps, the databases that we were comparing. So we're still working with scientists throughout the Caribbean to check on our work, especially for those areas that we weren't sure about. But so far, it seems like the differences largely depend on which island we're considering, and it's not clear whether the discrepancies between the different databases and our current map represent actual changes in mangrove area or just inaccuracies on those global databases. but if there are major inaccuracies in the global databases, then having accurate regional and local maps will be necessary for determining the actual extent of mangroves in a lot of those areas. So I was able to create an accurate map of mangroves, which will help with conservation and restoration for the Resilient Islands program, but other accurate maps for different regions will also be necessary. And even the extent and status of mangroves is important in Hawaii. So, like I said, mangroves are subtropical and tropical species, but they are not native to Hawaii. So they were introduced in the early 1900s to Molokai, and since their introduction, they have spread rapidly. And estimates from the early 2000s put them at 150 hectares on Molokai and 240 hectares on Oahu. But the management of mangroves on Hawaii is heavily debated. There's a lot of concern about the impact of mangroves on native bird habitat, nearshore communities, food webs, as well as the disruption of Hawaiian cultural sites, especially because they just kind of grow out of control and they've been able to spread so rapidly. So mangroves have been removed throughout much of Hawaii. However, they do offer some benefits, even here where they're not native, such as reducing sediment runoff into the coral reefs, providing habitat for native fish, offering coastal protection, and carbon storage. So even in areas where they're not native, I think mangroves can still offer some benefits, but understanding their current extent will be helpful in making those important management decisions, especially here where it's so heavily debated whether they should be removed or not. And lastly, I would just like to acknowledge Nature Conservancy and Hawaii Pacific University, and thank you for watching my video.